Mr. Rajat Gupta. He is the CEO of TESOL. With his strong inclination towards technology and his passion for product development, Mr. Rajat is the mastermind behind TESOL's proprietary technology and its chief innovator. Mr. Rajat brings in a deep understanding of product design, technology, commercialization, and market entry strategy, and has been instrumental in the leading the organization from its inception to the date as its CEO. Today, Mr. Rajat will walk us through last mile cold chain in India, latest trends and technologies. So, delegates, let's welcome Mr. Rajat.
So I'll give a couple of lines of introduction about our company. So TESOL has been a relatively more recent player in the cold chain space, and our primary focus is on passive cooled and thermal energy storage based technologies for cold chain. And we work across both food and pharmaceutical sectors and across the value chain. Today's conversation will keep more focused towards the last mile because that's the topic, and I'd like to give a certain perspective that we've built over the last few years. So one of the things that I wanted to highlight and I wanted to iterate was that cold chain, we have spoken a lot about reducing wastage, and I think it's a very important factor. But a key thing about cold chain is not just about reducing wastage, but it's actually for a brand. It is fulfilling their promise, right? So if you're buying a certain dahi or if you're buying a certain chocolate, you want it to be given to you in a certain form and shape, right? And that is what is the brand trying to achieve. And for that, they need cold chain. If you want your customer to experience your product in the way that you've designed it and you wanted it, that is what cold chain is doing for you. So while traditionally cold chain has been very, very focused on impacting wastage, storing produce for a longer period of time, price arbitrage, all of these have been factors in through which cold chain business has worked. I think now we are seeing a lot more of the flow kind of a cold chain where commodities are not stored for a long time, but they're stored for an optimum time in order to fulfill demand. Right? And that's where the last mile cold chain comes into view. Also, from a business model standpoint, you are not looking at only a cost reduction or a wastage elimination as your source of creating value out of cold chain, but you're looking at in some way increasing the price, increasing your revenue, and increasing your reach as a way of monetizing the cold chain assets that are put in the field. So I think these are two things which are in some way dependent, but I think we talk a lot more about wastage and little less about how other monetization methods can be built for cold chain, and that's what I'd like to highlight in the last mile piece. So when we talk about last mile, so last mile, when I say, it is typically the distributor to retailer and retailer to home kind of movement. So this is what I'm restricting myself to. And in that, what we've seen is most of the products, when they move from along this line, their quantities are much smaller. They're also multi-temperature in nature. And given the retail infrastructure in India, if you take general trade, for example, general trade is 85% of our overall trade, and there the quantities that have to be delivered at every shop are very small, right? So the traditional cold chain solutions, which is the reefer truck and the refrigerated containers that are put on smaller trucks as well, are not as viable, because the capacity utilizations may or may not make sense, because small quantities, frequent deliveries, so even the temperatures get impacted. On the other end of the spectrum, you've got the ice boxes with gel packs. You've also got the dry ice. So there, again, with the current set of solutions, there is a question on the reliability of the solutions. In winters, they'll work. In summers, they may not work. Peak summers, you will have spoilage and rejections. And dry ice is not as sustainable, as easy to use. The pricing is highly fluctuating. In Bombay, you'll have at one price, and Calcutta, you'll have at a different price. So it's an area which requires a certain intervention which can standardize the way in which the last mile movement happens. And this may be very specific to the kind of retail infrastructure we have in India and very different from what we have in the West. So what is that we are proposing? We're saying that you need to make these three other goals: viable, reliable, and sustainable. So viable is it should make sense to deploy it based on the price of the product. Reliable, it should work all the time, independent of the season. And sustainable, it should not have an adverse impact on the environment, and preferably not using a fossil fuel. Right? So in this, I think one of the key thought processes that went through our mind when we were looking at this as a solution is that when we are trying to save a commodity or preserve a commodity, you need to maintain the temperature of the product and not really the temperature of the area around the product. All our cold chain has been designed to cool spaces, and cooling spaces does not always mean that you cool the product, and it is not always required to cool the space in order to cool the product. So for example, when we feel cold in winter, we wear a jacket. We don't always need the whole room to be heated. We can wear a jacket and feel comfortable about it, right? So we are trying to save ourselves, but we are not trying to cool the whole or heat the whole area, which is what we are trying to do with these kind of solutions, because here you need to be able to reliably and viably move even a small piece of butter. So a simplification of how it works is you've got something called a phase change material, which is a liquid which freezes and melts at different temperatures. Depending upon the temperature of your product, you can freeze that phase change material. We can keep it along with the product, and then you can move it in an ambient truck, depending upon what your requirement is. Your requirement could be anywhere from an hour movement to maybe 3 days, 4 days kind of movement. So depending upon your requirement, the solution can be tailored. Now, how is it different from a regular gel pack and a box? Is that using these specific engineered chemicals, you are able to get a much more precise temperature profile in the box or for the product compared to what you used to get with a gel pack, which is essentially freezing and melting water. So depending upon the product, you can choose the right set of solutions, which will give you a reliable band of temperature for the period of time that you need. So how is it becoming viable? So I'll just walk you through these steps. So we say that there is a reduction in the cost of ownership. How is it reducing the cost of ownership? Because here you don't need a dedicated fleet. You can catch hold of a porter, you can catch hold of any kind of a ambient rental vehicle, which is available at the same cost in the summer and the winter, which may be different for a refrigerated truck. And so your costs remain standard, and there is no issue of a vehicle breakdown because you're not dependent on that particular vehicle. Right? The fact that there is no that this whole setup, if you look at a part load level, let's say moving around 400-500 kgs of material in these boxes versus moving it in a reefer, there is a significant reduction in the initial costs. Payload, of course, is variable, and since there is no dedicated fleet, you can, if it's a smaller payload, you can move it on a bike or a 3-wheeler or a 4-wheeler, depending upon what the requirement is. No maintenance cost because there's nothing that breaks, and there is zero diesel costs. So there is absolutely no fossil fuel which is required in making this kind of a cold chain movement. At the same time, as I said, the technology ensures that the temperature is close to the range which you need. So if you need a -18, -20, you will get a -18, -20. It's not that you're compromising on the quality. There is redundancy because if the vehicle fails, you can get another vehicle with multiple drops. Each of these boxes gets opened only once or twice, so you don't lose temperature, and so there is much higher reliability if you have larger number of drops. Second last slide. These are a few examples of how this actually practically works. And finally, I just wanted to give you a sense of how this has changed for us, because we're talking about the next year and how next year or next 5 years are going to look. we've done a very specific market study on what is the potential for distribution cold chain, and this only talks about the chain that I've shown. And it's and for the equipment itself, it's almost a $1.5 billion opportunity, and this is over the next 5 years. This is growing at a very, very fast rate. So this is something that we all should look at. We all should try and collaborate and see how we can serve the country and sort of get this kind of infrastructure built in the country. Thank you so much.